In this video, we're going to talk about the converse of the Pythagorean theorem, which is where we can use the Pythagorean theorem in order to prove whether or not three side lengths could possibly make a right triangle. So we know that in order for three side lengths to form a right triangle, a squared plus b squared has to equal c squared. So the leg squared plus the leg squared has to equal the hypotenuse squared for three side lengths to be a right triangle. And for something to be a right triangle, it's going to have at least one right angle. So we're going to use the Pythagorean theorem to prove whether these given side lengths are right triangles. On number 1, we have three side lengths, 5 inches, 12 inches, and 13 inches. The longest side length will always be the hypotenuse. So for these three sides, 13 is going to be our C. And then the other two side lengths are going to be our legs, which are A and B. And it does not matter which is A and which is B. Now we're going to plug them into the Pythagorean theorem. So we know that A squared plus B squared has to equal C squared for three side lengths to be forming a right triangle. We're going to plug these in. So A is 5, B is 12, and C is 13. Our next step is to simplify both sides of the equal sign in order to see if they equal each other. So 5 squared plus 12 squared equals 169. And 13 squared also equals 169. So all I did was plug each of these into my calculator. So I plugged 5 squared plus 12 squared into my calculator, and I got 169. Then I plugged 13 squared into my calculator, and also got 169. So because a squared plus b squared does equal c squared in this scenario, this is a right triangle. So yes, these side lengths could form a right triangle. Number 2, we have 35, 30, and 18 feet. So the hypotenuse is 35 feet because that is the longest length. So we label that C, and then the other two A and B. So we're going to plug them into the Pythagorean theorem. 30 squared plus 18 squared equals 35 squared. We're going to simplify each side of the equal sign. 30 squared plus 18 squared is equal to 1,224. And 35 squared is equal to 1,225. So in this case, because a squared plus b squared does not equal c squared, because we found that a squared plus b squared is equal to 1,224, and c squared is equal to 1,225, these side lengths could not possibly form a right triangle. So 35, 30, and 18 could not be possible side lengths for a right triangle. Next one, the hypotenuse is 19 because that's the longest side. We label that C. The other two we label A and B. So when we plug it in to the Pythagorean theorem, we have 6 squared plus 14 squared equals 19 squared. We're going to simplify both sides of the equal sign. So we have 6 squared plus 14 squared, and we get 232. Then we have 19 squared, and we get 361. So for this example, because a squared plus b squared does not equal c squared, these side lengths do not make a right triangle. Number 4, 70 is going to be our hypotenuse. That's our C. We have A and B. So when we plug that into the Pythagorean theorem, we have 42 squared plus 50 squared equals 70 squared. 42 squared plus 50 squared is 4,264. And 70 squared is 4,900. So because a squared plus b squared does not equal c squared, the side lengths 42, 70, and 50 could not possibly make a right triangle. Next, 197 is our hypotenuse. That's going to be our C, and the other two are A and B. So when we plug that in, we get 195 squared plus 28 squared equals 197 squared. We're going to simplify both sides of the equal sign. 195 squared plus 28 squared is 38,809. And 197 squared is also 38,809. So because a squared plus b squared did equal c squared, we know that the side lengths 195, 197, and 28 do form a right triangle. In our last problem, 15 is our hypotenuse because it's the longest side. That's our C. We have A and B. So we have 9 squared plus 12 squared equals 15 squared. We know that 9 squared plus 12 squared is 225. And 15 squared is also 225. So because a squared plus b squared did equal c squared, we know that these three side lengths could make a right triangle.